All right, this is lesson 3-2, graphing linear equations. There's that word again, linear. So obviously we're going to be graphing equations that form a line on the graph. Okay, and we're going to start with some warm-up exercises because I think several of you need a little bit of practice with this. And we're going to rewrite the equation so y is a function of x. So if you want to, you can pause the video and do this, or you can go through and do this with me, or do one with me and do one by yourself. Okay, so the first thing we're going to do is we have to isolate this term by itself. So since this term has a 3x being added to it, we need to subtract a 3x from both sides. Now if you understand this, you can skip this part of the video if you get this, or at least try it and make sure that you understand it. I don't mind you fast forwarding through this. Okay, positive 3x, negative 3x, add to 0, leaving us with 4y, and then over here we have 16 minus 3x. Okay, now to get the y by itself, we divide the entire equation by 4. So that means we have to divide every term by 4. So now that leaves us with one y, or the y by itself, which is what we want. 16 divided by 4 is 4, and then 3/4 x. Okay, that's our first answer. Let's go ahead and go back. Pop that other answer up there. Don't want that yet. So again, now we have to isolate the negative 2y. That has to be isolated. And this time we have a negative 6 being added to the negative 2y. So we need a positive 6 because a negative 6 and positive 6 are what add to 0, and that's what we want. So we're going to add a positive 6x, positive 6x to both sides. These add to 0, and I'm left with negative 2y on this side, and over here a negative 12 plus 6x. Again, I could change the order if I wanted to. It's totally up to you. Now I need to divide both sides by a negative 2. So I'm going to divide everything by a negative 2. Okay, leaving with just the y. And negative 12 divided by negative 2 is positive 6. And positive 6 divided by negative 2 is negative 3 and negative 3x. So there are my two answers. I've turned these equations into where y is a function of x. I've moved everything around where the y is by itself and showing you what the y equals in terms of x. And let's check. Notice how the answer is written. The x term is written first, and they take that negative that we have right here with the x, and they make sure they keep it with the x term, and then the plus 4 becomes, or the positive 4 becomes plus 4. Same thing here, negative 3x plus 6. All right, so let's move on. And that's why we practice that, because to graph the equation, negative 2x plus y equals negative 3, it's just like what we did yesterday in 3-1, or 2 days ago in 3-1. However, in 3-1, the equation was already solved for y. We had a function already, y equals something, and that way we could make that table of values. So the first step we're going to do is solve the equation for y. So here is our equation, and we're obviously going to add 2x to both sides. Just showing you what we're going to do because we need to get the y by itself, and a negative 2x needs a positive 2x to be 0. So there is what we get. We get y equals positive 2x minus 3. So now we have our equation solved for y. We have y as a function of x. So we're going to make a table. So on your notes, go ahead and make a table. Look at the values they choose. Now on your notes, you have your chart like this. You have an x and a y. So on your table, go ahead and put your negative 2, negative 1, 0, 1, 2. Notice we always keep the values of x some of the easiest numbers to work with because that's just easy to graph, easy to plug into our chart. And when you plug that in, let me get that equation real quick. Y equals 2x minus 3. Okay, so here's our equation. You probably had it. I just wasn't able to see it. So when you plug in, negative 2, you end up with 2 times negative 2, which is negative 4, minus 3, which is negative 7. So we're going to go ahead and write these values like this. just so that you can see the coordinate points or the ordered pairs from left to right. It's a little bit easier than seeing them up and down. So there are our ordered pairs. So now it says plot the points. Notice the points appear to lie on a line. So as we plot them, and you should plot them on your graph that you have in your notes, notice they do lie on a line because this is a linear equation. It has a constant rate of change. It's always going to be a linear equation. When it generally looks like this, when you have an x and a y, it's generally going to have a linear relationship. Okay, so that's that. It's very similar to what we did in 3-1. We're just going to actually now have to maybe solve the equations for y. All right, next thing we're going to do is we're going to graph a line, a y equals b, where b is a constant, and x equals a, where a is a constant. So here's the examples they've given us, a line y equals 2, and the line x equals -1. So let's see what they look like. For letter A, for y equals 2, okay, it doesn't matter what your x value is. It tells you that y is going to equal 2 no matter what. So let's look at this. For every x value, when x is 0, y is 2. When x is -2, y is 2. When x is 3, y is 2. It doesn't matter what your x value is, your y is constantly a 2. Okay? Notice the line y equals 2 runs perpendicular to the y-axis. Okay, the y-axis runs up and down, but a y equals 2 line is going to intersect that y-axis at y equals 2 because it's going to run, if every value of y is always going to be 2. Okay, so that doesn't, so you should be able to look at your coordinates, look at your y coordinates. Every y coordinate is 2 because that's what our line is, y equals 2. So you can guess when our x equals 1, what that's going to mean is for every value of x, or excuse me, no matter what your y value is, your x is always going to be -1. So it's going to run the opposite direction of the x-axis. So whereas our x-axis runs horizontal, our x equals -1 runs vertical. Okay, so no matter what your y is, your x is -1. And look at every single x value in points on this line. Every x value. And you guys, kids get this confused constantly. So if you need to plot a couple of points and check those x values or those y values and make sure they match what you're seeing in your equation, that would be a good thing to do. Just make sure, because kids want to do x equals -1. They want to go this way, like along the x-axis, instead of doing it through the x-axis. But just think about it. If x equals -1, it has to pass through x equaling -1. Has to pass through that point where x equals -1. Okay? All right. I think that's it for your notes. Okay? Here's your guided practice. If you would do those on your own, and you could bring those to class. If there's some that you have a question on, then bring those in. Maybe you don't have to do them. You're going to start by making a T-chart and going from there. All right. That's it. End of video. Except I don't have my recorder.